Hello, tonight I'm going to be doing something that's considered possibly dangerous, and if you do play with electricity, you've got to be aware of the consequences. The object I'm about to build tonight could result in a serious case of death if you're not careful, so it's something you should be aware of. What am I going to do tonight? Tonight I'm going to build a piece of test equipment for testing vintage capacitors. Well, in fact, for testing any capacitors, but normally you only test the old ones. So if you'd like to stick around, by all means, enjoy yourselves. Thanks very much. Okay, so let's start by going through what we've got here. The first thing to notice is that here's a circuit diagram. I've actually got a drawing for once on my page, and this comes from Max Robinson's site, Fun with Tubes, and it's an absolutely fantastic resource for anybody who's interested in valve radios, valve amplifiers, any valve equipment at all. And looking through what we have here, pretty much all of these components are standard in my box, bar this transformer. This transformer was one that I don't have an exact replacement for, but I've got one that's fairly similar. So basically what you have is you have your mains input here, and it's stepped up to a reasonable level of AC. Now on this diagram it can step up to either 200 or 400 volts of AC. It's then rectified by this diode, which charges this capacitor. While this capacitor is charging, you also have a resistor and a meter in parallel to the capacitor, and you put your capacitor under test on here. Now if the capacitor is leaky, effectively there will be a voltage between here and here, whereas if it's not leaky, the thing should remain open and the meter not read. Is obviously there is this section here which is used for electrolytics, and you can reform old capacitors. Some of them can be recovered, some of them can't. Okay, so here's the first item on the bench, and it's a transformer from an old Philips reel-to-reel tape deck. Now as you can see, it's a multi-voltage input device, and you can set it for whichever voltage you have. Now currently in the UK we are showing 241 volts. At peaks we only go down to 230. Now this transformer doesn't actually go to quite the high voltages needed in the circuit diagram, but with a little bit of jiggery pokery, and by turning this to say the 110 volt setting when you're putting 240 in, it should double what it does, and that should be within its safe limits for the insulation. If not, it'll go up in a pile of smoke when I'm using it. We also have a mains lead, again off an old British piece of kit, and the reason I say old is because the colours in this lead are the old ones. The current British colours are brown and blue with a green and yellow earth line. So this dates this piece of wire to around about 1970 at the latest, I believe the wiring change was. So that's going to be the feed cord. Now as I say, I've got a mounting for this already, and the whole lot is going to go into this black box. Let me move that to the back for the moment, which has got various holes drilled in it to take various items, not least of which is a meter for the front panel, so that you can actually see what the leakage current is. It will also have the LED here, and it will have the power switch and the range switch in this side. On this end will be the two terminals for the actual high voltage output to test the capacitors, and on this side will be the input voltage panel, which is this panel here, and also the mains in, which will go through this hole here. It'll probably just be in shot, hopefully, so that you can see exactly what's going on. There are a few other bits and pieces in this box, which, you know, are the switch, the terminals, the knobs, and some extra screws. Also, let me move this back out the way. It's a little tip that sometimes I use. I've got to admit I don't use it very often, but if I'm only doing a small number of components, it's a piece of cardboard. If I zoom in, you could see. I'm going to turn the light up a bit if I can. See if I can get you in. No, wrong way. There we go. You should be able to see there that I've written down the values of these resistors and the diode, and just stuck them in this bit of cardboard, so when I want, you know, the 10k resistor, well, there it is. If I want the 220k, there it is. And you pull them out. I've seen people do this with polystyrene foam. I've seen this done with sticky tape and taping things to cards. But yeah, it's just a little tip that I thought I'd pass along. So let's come back out. There we go. Hopefully I'm not washed out again. I probably have. Let's just drop the exposure down a bit. There we go. So that should be about right. Yes, sorry for the cuts on my hands. They're just there because the day job gives me those sort of things sometimes. Right, so the first thing I've got to work on is this transformer and wiring it to fit the box. So at the moment, this is the original wiring that came out of the tape recorder, and I don't need all of this wiring in particular, so I'm going to take some of this off and start again, and just basically shrink it down, because the layout inside the box is going to be something like that. So that's going to be the start of it, and obviously I can use some of the spare bits of wire to actually wire in the fuse holder and things like that. So let's get the soldering iron warmed up and start assembling things into the box. Okay, so here we are on the bench now, and I know it looks like I've done a lot, but I haven't really. What I'm going to do is I'm going to go through what we have done at the moment. The first thing is the mains power cable comes in and hits the fuse. One side of the fuse goes off to the push button here, which is your basic on-off switch. The other side goes to this point, which actually goes to the 245 volt input for the transformer. The black wire coming in from the main supply goes straight to the transformer, so it's the hot side that's switched. What we've got coming out of the transformer is we've got two separate wires. It is actually safe at the moment because there's nothing really connected. This is just off the 6.3 volt secondary, which will be just to power the LED, so that's what I'm going to use there for the LED. And you've got these three wires coming out here. Now obviously they are a touch long, and I've got them connected here, and the reason I've connected them up at this point is because I wanted to show you that where the original design, let me get the original design back again and turn the lights down so you can see it. Right, where the original design here calls for a 400/200 transformer, I haven't actually got one of those. My one is a 100/100 transformer, so rather than a 140/140. So I've got the choice. I can either double up the input voltage to get the 400 out, or I can just use the 100/200 and it will run, you know, slightly lower voltage than the design here. So that was just a quick sort of blurb. So here's the meter actually connected. I'm going to turn the lights back up so you can see what's going on. I think you can see the meter. Can you see the meter? There we go, that's it, the light's off the meter. So what we've got at the moment is we've got the two outer windings of the transformer connected up. The centre tap is here and that isn't connected at all at the moment. So if I put the mains electricity on and then lift the box and push the button, you'll see instantly we've got 204 volts coming from end to end of the transformer. Now if I turn that off and I connect one side, doesn't matter which, to the centre tap, if I can get it in there without zapping myself, this is where it gets electro-boomish. So if I now push the fire button, as they say, as you see we only get 102 volts out of the transformer. So it's about half of, well not just half, no, it's about 2/3 of what the original design calls for. So I'm still not decided as to whether I'm going to go for the centre tap version or the other version. I might just do the centre tap anyway because I can. With that I will actually use this switch to do the switching, although they've actually say it's 6 amps at 125 volts. There's nowhere near going to be that amount of current going through it. It's going to be microamps if anything. Well, as the meter says, it's a 50 microamp maximum meter, so this will be well within the rating, and we won't be switching it live at all anyway, so the contacts will not actually arc across because you won't be flicking it while the machine is energized. So that should work quite well as it is. So that's just to explain where I've got so far now and to show that the centre tap's there. I suppose the first thing to do before I carry on is to take off the main supply so that none of this is live. As you see, the panel is in on the side and the fuse is in there, and that is a 1/2 amp fuse. So you know, it's perfectly safe as it stands now. There's no capacitors in here. Everybody warns you about the dangers of working on high voltage equipment. The reason is these little beasts, these things store charge, and even after it's switched off, if you haven't got any way of discharging it, which this device will have, it can store a charge and it can give you the zap at the full voltage it's stored. So you really don't want to be messing if you don't know what you're doing. Anyway, enough waffle. Let's get on with the wiring, and the next thing to do is I'm going to work on taking the wires out from the transformer and following through where they've got to go. Now I am going to use a piece of recycled tag strip to actually make all my connections, and that's going to go in the bottom, and that's purely there. Let's bring that back into shot. That's going to be there because obviously it's the nicest way of doing anything. Schematic, I suppose. Let's look at the schematic and see what I have to do. I have to take one wire from the transformer straight to the terminal at the top. Now if I use the purple, let's take the meter out of the way because we're not measuring things at the moment. Come on, out you come. Let me get myself organised, I'll be back in a second. So, as I was saying, you can put it on the strip. So now from that centre wire, if I follow the schematic, so from that centre wire we go to the diode, which is this beast here. So it goes to the diode. So I can lay the diode in the top there, like so, and then cut off the excess. So let's just lay it in. Go on. And I could leave a longer length. I could push it forward a little bit, like so. Again, this diode has a very thick lead on it, so it will take a lot of heat. Just going to push that down so that I can solder it both sides. Now, soldering it both sides is obviously unnecessary, but I think it just makes a more rigid structure. It doesn't need to be done. Okay, so it goes from the diode, and then you have the capacitor on the end of the diode to the earth wire. So the capacitor will go from positive, which is this side, like that, to negative, which is that side. Now, I could keep them well spaced apart, like so. So if I put that through the hole there, the hole's not open on the other side, so that's the capacitor. And again, what I can do is I can wrap that round the lead like that. Which makes a similar thing to a J-hook, so it's flowed onto the diode lead and onto the capacitor's lead. Okay, so since the battery on the camera ran out, what have I done? I just got carried away working, and I didn't notice. Terrible, aren't I? So what have I done? Well, I've put the LED in, and I've wired up the negative terminal. Now, what have I got left to do? I've got to connect the meter to the positive terminal, which also goes to the switch, so it goes that way and that way. So there's the positive terminal, that's the negative terminal. The negative terminal goes out and also to the wiper of the switch. The positive terminal goes to a 10 meg resistor. So there's a 10 meg resistor, which I was just going to tin the end off. So there we go. All that's left to build now is the switch assembly, and that I'm going to do as a standout bit of the board. Okay, back again for building the switch. Now the bench is a bit mucky where we've been doing all the other bits, but now I can bring in the resistors. And what I can say is, with this particular switch, it has 5 clicks, obviously 6 ways. This is the common input, and this is the first output, which we're going to leave open. Then we'll just go down in the ranges until we actually get, you know, the other 5 connections, the other 5 here. 1, 2, 3, 4, 5, all connected up. Obviously this one will go to the common wire where that diode is. So we go to our resistor pile, and the way I'm going to do this, because they all have to go to a common point, I'm actually going to mount them in like this, so that there's no chance of them shorting out. And I'm just going to bend it over, leave a little bit of a tab so that I know where it's going to be, and I'm only going to solder one side so that I can bend it vertical again. way the resistors shouldn't be able to connect with this metal part of the switch, and there will be sufficient distance there that you're unlikely to get arcing at DC. So we've done the first one. Let's again. So now that is totally complete, bar a bit of glue. So there's our reference, there's the 10 mega ohm meter bottom, that would fit in there like so. Obviously that needs gluing down, but we can now just move all the bits of wire off the bench, because they could gum up the works. And a bit of cardboard. So let's just turn that over like that. Right, okay, let's test some capacitors. We're plugged into the mains, the meter's sitting here, it's in the 0 position, and let's see if we can find a, so that's a 0.001, that's probably too low a value. What's that one? That's also a 0.001, again probably too low in value. I've got anything that's reasonably large. Maybe that one. Maybe some of these mustards will do the job. So let's just connect the probe lead or the clip leads onto the capacitor. Come on, get on there. Right, okay, so what we've got to do is we've got to push the button and hold it, and we've got to see these are 125 volts. I don't want to add 200 volts over it, I only want to put 100 volts over it, otherwise it's likely to go pop. So let's hit the button and we get no kick. Now it looks to you like the meter is reading above 0, but actually what you've got, let me just have a look here, you've got the shadow of the needle because of the angle of this light. See, if I block that light you can now see that the needle's at 0. So let's just come out of that one. Obviously if I turn the lights off you won't be able to see anything at all, so it looks like that one's a good one. Let's put this one in. And again, we have no kick, we have no, in fact the meter's staying pretty much at 0, so I would say that it was either too low or too, or good, basically. So, for a quick project, that certainly looks like a good one. What else can I show you? Well, the one thing that I have got is a very conductive workbench. This part here is rubber. This is actually a conductive mat. So without the button on, let's just see what sort of reaction we get from the meter, and that's showing that it is actually holding a charge and it is discharging slowly. Now, one of the reasons I put the rubber mat down was because I didn't want anything on the bench to be either conductive to ground or or to me really. It's great thinking about anti-static and these mats, but as you can see, even without putting any voltage through, it is actually showing up that there is a voltage across the terminals. Now the closer I put it, as you see, I wonder if I can charge it up if I rub the mat. It's not charging on, which is quite a good thing, but you know, make it a bigger capacitor. Yeah, see, it's still showing that there's a current there. Now this shouldn't provide a dead short, but we're going to go, and that's showing that it's leaky because the current is not dropping at all. So there we go. Even without the thing, I've charged the bench up now to 100 volts, which is quite a nice little capacitor, isn't it? Let's not play anymore. I could end up damaging something here. So, one test meter, mains powered for testing capacitors. You can test electrolytics with it, but you have to apply various formulas to calculate the leakage and to see whether they're any good or not. So they take a little bit longer, but they can be done with this box. As I say, I will put markings on it when I'm ready to. At the moment now it's 5 to 6 in the morning, so we've been at this for 5 hours as near as. So there we go, a little weekend project for those of you that want to build something up that could be useful. So if you're watching this, thanks for sticking around till the end of the video. Hopefully you'll like and subscribe, and hopefully we'll see you again soon with a different video. Thanks very much for watching. Bye bye for now.